morning, friends and dear students. It gives me immense pleasure to be here again for my course, Flight Mechanics. This course is for the 4th semester Aeronautical students of Institute of Aeronautical Engineering, Hyderabad, India. I am Dr. Yagya Dutta Dwivedhi, professor from Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad, India. Today I am going to take the new module, that is the maneuver performance. In this, I will be discussing about turn performance of the jet aircraft. So here onwards, we will be having some accelerated flight. As of now, we have completed our 3 units. In all 3 modules, we have not considered anywhere the acceleration. We all have unaccelerated flight. A simple case, we have assumed that there is no acceleration, velocity remains constant. But in the real practice, it is not so. Especially in the, whenever you are turning, there is a change in the vector direction, and that is also, there is a change with respect to the time. That also makes the system as an accelerated flight. So now we are going to discuss here some topics. So in this we have level turn performance, important parameters of load factor, variation of maximum load factor versus airspeed, forces during turns, radius of the turn, rate of climb during turn. This we will be discussing. So in my introduction part, I will just, what is the turn? As of now, we have discussed the climb, then cruise, then descent. In all these 3 discussion, we have assumed that there is no change in the velocity. Velocity remains constant. But another case we are going to discuss today is a coordinated turn. When we talk about the coordinated turn, it is in the same plane. Plane means there is no change in the height. Altitude remains constant, and your aircraft is only turning. Turning is only performed by the help of the rudder, and no drop of altitude. Altitude only, it may roll like this and it will turn, but no change in the vertical height. That is called the coordinated turn, and steady means there is no change in velocity. Acceleration remain constant. So we will be first taking the case of very simple case where we will see that the acceleration is constant, and then further we will see that how the acceleration is affecting. We will be also finding out this angle. If you see here, angular rate and the turn rate, radius of the turning, and other parameters we are going to find out in this topic. So level turn performance of the jet aircraft. The load factor is defined as the ratio between the total lift of the aircraft, that is L, to the weight of the aircraft. There are 2 types of maximum load factors. Maximum possible load factor. So this load factor is depend upon the engine thrust, how much the engine is producing the thrust. Another one is the maximum allowable load factor. That load factor is depend upon the structural integrity of the structure, the material, and the other parameters, and that is called allowable load factor. So the possible load factor, it is from the aircraft how much it can generate, but allowable load factor is a design parameter, in that how much it can sustain the load this aircraft can sustain. The maximum possible load factor for a sustained level turn is constrained by the maximum engine thrust and the power, and the maximum allowable load factor for a sustained level turn is constrained by the maximum structural strength. For a fighter aircraft, the maximum producible load factor by the engine thrust is often greater than the maximum tolerable load factor by the aircraft structures. So for the fighter aircraft, the producible load factor means the load factor which is produced by the aircraft, that is much higher than the tolerable load factor of the aircraft, which is by the help of its structure. Means the engine is much powerful than its structure. However, for the general aviation aircraft like Cessna and other small aircrafts or your passenger aircraft, Boeing, Airbus and all, the maximum producible load factor by the engine is less than the maximum tolerable load factor by the aircraft structures. Now we will see the four important parameters are described here. One is the maximum producible load factor, then corner velocity, maximum of the maximum load factor, airspeed that corresponds to the maximum of the maximum load factor. Maximum producible load factor, if you see, first one, we will see here that as the bank angle is increased, the magnitude of the lift should be increased too. So the increased CL is given as CL is equal to 2nW by rho V square S. As L increases, the drag due to lift will increase. Drag is equal to half rho V square S CD, half rho V square S CD naught plus KCL square. To maintain a level turn, the engine thrust should also be increased for cruise level flight. T is equal to D. So here, as you increase the lift, your drag will also increase, because in this there is a turn CL. So if you increase the CL, drag will be also increase. So increasing the CL, drag will also increase. So any maneuvering flight, we have to take care of that. We need extra lift. To counter that extra lift, or due to this extra lift, there is a extra drag. So to counter this extra drag, we need some extra thrust also. So now, okay, we will discuss about coordinated turn. So here I will be just discussing about deriving some equations and all. So here I will draw the diagram of aircraft for this is your fuselage. So I am just making a turn. So this is the somewhat turn here. So if you see here that this is the horizontal tail, and this is your vertical tail, and these are the wings. I will also here just show by my aircraft also. These are the wings, these are the horizontal tails, this is the vertical tail. And here we have the turning angle. I will just put here like this. This is the phi or phi. So if I make this angle, this is your front view. If I make this thing here as a side view, so how your aircraft will look like? So just this is here lift, So from here, if I draw like this, then I draw like this component of this. So now I will draw the side view. In side view, we will see the first, it is the horizontal. From the horizontal, we will see the thrust and all. So this is the your velocity V, and here only the thrust. That is the another thing. Now from here, if you see, I will make the weight again from the, this is the your weight. Lift will act the same. I am putting the black. So this will be always opposite, perpendicular to the V. So this will be somewhere like this. This is the lift. This is the gamma. Here is the phi. This angle is also phi here. This is also phi. So what will be this? This one will be L sine phi, and this will be L cos phi. Okay. And this will not be W, because this is the W. So this is the projection of this. This is the W cos phi. So this is the W cos gamma, not phi. W cos gamma. So this here, this weight will not be W. This will be W cos of gamma. Okay, understand? Because we are taking a camera here. If you put a camera here and you take the projection here, so this will not be W, this will be W cos gamma. This lift will not be lift, this will be equal to the L cos of phi, because there the projection of this will be L cos phi. So you will get opposite to this L cos phi. Very important to understand these forces, this. And now if I draw the top view, I am just may not be able to draw very circle, but I will try to. So this is the circle and this is the radius R, and if your aircraft is flying somewhere here, I will just draw the aircraft. This is the velocity, which is V cos gamma, and this will be the force, which is L sine phi. This is the force which is here. Okay, and this will create the centripetal acceleration. So I think I have done all the things here. The R is equal to radius of turn. Here V cos gamma is a projection of V on top view. V cos gamma. This is a projection on the top view. You will get V. This V, you will get V cos gamma here. Okay, so I have drawn here. Now we will discuss about equations of motion, how the forces are acting and how we can do it. I think it is very much clear. So now forces on the radial direction. Forces on radial direction. Recall that there is acceleration due to turn and this acceleration A sub r is equal to Vt square by r, where Vt is a tangential velocity So from here onwards, we will see that here this t sine phi, if you see this L sine theta not phi, it is all phi. L sine phi. So we can see that this L sine phi here, L sine phi is equal to ma is ar. So here L sine phi is equal to m into ar, and we know that ar is equal to m Vt square by r. So here L sine phi is equal to m Vt is equal to V cos gamma. Vt tangential is V cos gamma. So here we can write V cos gamma square divided by r. So this is the velocity which is mentioned here. So now we can write m is equal to w by g V square cos square gamma by r. This is the equation number 1. Now forces in the direction of the flight. I will change the color. I will change some blue color. Forces in the direction of the flight. So in the direction of flight means V. In this direction, here we have the drag. I have not mentioned. This is the drag here. Here we have the thrust. So we can write it in this way that here T minus D or T is equal to D. One component of this thing will be here. So here it will be W cos of gamma. So here if you see T is equal to D plus W sine of gamma. So here we know that D is factor of drag coefficient. So we can make it in the drag coefficient form. So we can write that T is equal to D, we can write half rho V square S W CD naught plus CD naught L into CL plus CL square by pi E aspect ratio plus W of sine gamma. This is the equation number 2. So here I will write 1 star, here I will write 2 star. Now in the radial direction, forces in the radial direction. So here I will write the forces in radial direction. So what are the forces in the radial? If you see mv square by r, because if this is turning in this, so this radius, it is turning with the radius. So we know that here L cos phi, this L cos phi, it is perpendicular in this. So here L cos of phi is equal to W cos of gamma, or we can write that L is equal to W cos of gamma divided by cos of phi. So we can write this L into form of CL, that is CL is equal to W cos of gamma divided by half rho v square SW cos of phi. This is the equation number 3, and I can write this as a star number 3. So now this 1, 2 and 3 equation, these equations will be used to solve the problem. So we will see here that how to find out the radius. So how to find out the turn So now from equation 1, if you see our equation 1, put equation number 3 into equation number 1. So we will see that what is the equation number 1. Equation number 1 is L sin phi. So it is L sin phi is equal to W by G V cos gamma square by R. V cos gamma square by R. So here we have the R. So from equation number 3, if you see here, equation number 3, we can put this value in equation number 1. So we can write this L so L sin phi by cos phi L. So we can write here that W cos of gamma into tan of phi is equal to W by G V square cos gamma divided by R. So here cos gamma W, this thing have gone. So we have now here tan phi is equal to V square cos gamma by R. If we solve this thing for R, we will get R is equal to V square cos of gamma divided by here G dot tan phi. So this is the equation for turn radius. So this turn radius is depend upon the velocity and rolling angle phi and the climbing angle gamma. These 3 parameters are very important to calculate the climb angle. Now we have to find out this radius. Now we have to find out the climb angle. So now I will select the green, finding the climb angle. So how to, now we have to use the equation 2 has sin gamma. So putting equation 3 into equation number 2. So value of CL we have to put here. So we know that in equation 2, if you see here, T is equal to half rho V square CD naught, this all value. So here gamma is there. This gamma we have to find out. So other value just we will put from CL value from 3 to the 1 and then we will simplify it. We will get here that thrust is equal to half rho V square SW in bracket CD naught plus CD naught into L into CL plus CL square divided by half rho V square SW cos of phi so CD naught into W cos of gamma divided by half rho V square SW cos of phi plus CL square means W cos gamma by half rho V square SW cos of phi whole square divided by pi E aspect ratio into W sin gamma. So now if you multiply by half rho V square SW in above equation, then what we are going to get? We will get the thrust is equal to, half rho V square S CD naught plus CD naught L W cos gamma divided by cos phi plus 1 by half rho V square SW pi E aspect ratio W cos gamma by cos phi whole square into W sin gamma. So now we have to find out the sin gamma. So sin gamma is equal to T minus half rho V square SW CD naught plus CD naught L into W cos gamma by cos phi plus 1 upon half rho V square SW pi EAR W cos gamma by cos phi whole square divided by whole W. So this is the equation. This is the equation for climb angle gamma. Now we have to find out the climb rate. So I will take this climb rate for turn. How to find out? We know that VC is equal to V into sin gamma. If you see here, this is the V, this is the gamma, this is the VC, and this is V into sin gamma. So we know the sin gamma from this equation, and we have to add in this. So here we will get VC is equal to T into V minus half rho V square SW CD naught plus CD naught L W cos gamma by cos phi plus 1 by half rho V square SW pi E aspect ratio W cos gamma by cos phi whole square into V. So this is the, and whole divided by W, and this is the PR into this. So we will get is VC is equal to, and this is the PA. So PA minus PR divided by W. This is called P excess power divided by W. So this is the equation for the rate of climb during the turn. Rate of climb during the turn. So hope it is very well clear, and I have done with this. So this is, we got the same equation here. This is the rate of climb during turn, and it is called the p-axis divided by weight. So just I will skip this here. In the next class, I am going to, this is my references here: Aircraft Performance and Design, International Edition, McGraw-Hill's first edition, 1999. Else by ME, Aircraft Performance Theory and Practice, AIA Education Series, AIA 2. Any questions, please do mail me in this ydwedi@gmail.com. Please do like and subscribe this channel. I will also like that if anywhere I am doing some mistakes, do pardon me and write me so that I can correct it. Till then, goodbye and thank you. Please do join my next class. Thanks.
Like, share and subscribe. Hit the bell icon for more updates.